This is the third video where we've been looking and discussing general solutions. So in the first video, what we did is we outlined the entire idea behind the general solution, why we use them, and how they can be applied. Then in the second video, we discussed the first two types of questions that you can get. And in this video, we're going to look at type 3 and type 4. So to begin with, we're going to look at the third type of question we can get, and that is where we have a different ratio and a different angle. So different ratio and different angle. Now what's very important about this is that we have to make a contrast between type 1 and type 3, because you'll see that they're very similar in the sense we've got different ratios. So what many people tend to do is look at a question like this, for example, over here, and immediately they want to use tan like we would in option 1 or in type 1. But we can't do that here because of the fact that we've got different angles. So you know that the ratio, or that identity, where we say tan theta is sine theta over cos theta, all three angles have to be the same in order for it to work. Whereas in this case, you can see that this angle over here and this angle over here are very different. So we are unable to use this identity, which means we have to use other techniques in order to get the answer right. And the technique that we will use in this question, or in this type of question rather, is to use cofunctions. So you'll all remember the rules. We've got sine of 90 plus or minus theta equals cos of theta, and we've got cos of 90 plus theta, which equals minus sine theta, as well as cos of 90 minus theta, which is sine theta. So all of these over here are our cofunctions. And we've used them a lot up until this point from the reductions. And the way that we apply that here is basically choosing one side of the equation. And what I tend to do is gear myself more towards using the last one, that cos 90 minus theta, just because of the fact that when we look for a cos general solution, it's only got the plus or minus in front of it from that general formula. It doesn't have the 180 minus like sine does. So the way that we would do that is choose one side of the equation and then apply the identity. So looking at that left-hand side now, in order to apply the co-ratio of that cos 90 minus theta, all you need to do is simply reverse the rule. So it's as if we've got the sine theta, and we need to now go backwards towards that cos of 90 minus theta. And by doing that, all you have to do is change the ratio in front. So we've got sine, we change it to cos, and then place a 90 in front, but make sure it's the 90 minus and not the 90 plus. Because if we add the 90 plus in front, then we need to also think about that negative that comes. So make sure it's going to be 90 minus, and then take the whole angle down, which is x minus 40 degrees, like so. And just to prove to you that it works, you know that if we went and took a co-ratio with 90 minus, it would become sine of the angle, which was x minus 40. So this and this is equivalent if we use a co-ratio. So we can swap out the right-hand side, or the left-hand side rather, with this using a reduction. So we would now get cos of 90 minus x minus 40 is equal to cos of 10 minus 2x. So in this step over here, I'm subbing out the right-hand side with this reduction here. because of the fact that it's equivalent to what we started with. It's equivalent to sine x minus 40. Then let's just group our like terms inside this angle over there to get cos of 90, and then the negative distributes in. So it would become 90 plus 40, which would be 130 minus x is equal to cos of 10 minus 2x. We have now got same ratio, but different angle, and so it's type 2. And when it's type 2, the steps are to drop the ratio, write out both angles, but use our general solution. So we put that plus or minus in front from the general solution, plus the k times 360. Then we're going to use the plus first, so it's going to be 130 minus x is equal to positive 10 minus 2x plus k times 360, or it's going to be 130 minus x is equal to negative, and then if there's a negative in front, it distributes in, so it's going to become negative 10 plus 2x plus k times 360. And when we simplify that out, we would basically go ahead and group the negative 2 with the x, so we would get x, and then we would group the 130 with the 10, which would give us negative 120, because it becomes 10 minus 130 plus k times 360. Or on this side again, the negative x and the 2x, which would give us negative 3x is equal to negative 10 minus 130, which is minus 140, plus k times 360. And then when we simplify that, we divide everything through by negative 3. So we would get negative 140 divided by negative 3, and that would give us 46.67. So our answer would be x is equal to 46.67 plus k times 120. And remember, if you wrote that plus there as a negative, it's exactly the same thing. Just make sure that you divided that 360 by negative 3 as well. So that's a look at type 3, where we have to use a co-function and then change one of the ratios from either a sine to a cos, so that we have two equivalent ratios. And when we've got that, then we can simply treat it as a type 2 equation. Now we're going to be looking at examples that deal with quadratic equations and trinomials. And I suppose we could almost put an asterisk next to this and say that whenever we're dealing with equations like this, the most important thing to look out for is factorization. And the types of factorization that often come up are obviously our highest common factor. That's a very common one, but also trinomials. So in the next two examples, we're firstly going to look at applying a highest common factor, and then we're going to look at applying a trinomial as well, and maybe trying the quadratic formula. So this question says cos x minus 4 cos x sine x is equal to 0. And obviously the question would be find the general solution of this equation. So the way to do this is to firstly count out the number of terms you have. So you've got a term there and a term there. And whenever you've got two terms, the first thing that you want to look out for is, like I said, factorization. And two terms, when we're dealing with factorization, often leads us to either dealing with a difference of two squares or a highest common factor. And you can see very obviously immediately that this is where we would take out a highest common factor. So the highest common factor here would be a cos x from both terms. So when we take that out, we would get cos x is equal to 1 minus 4 sine x equals 0. And whenever we are dealing with a question like this, relate it back to when you've done quadratic equations in the past. So let's think of it like this. Imagine I gave you an equation and you solved it and you got x minus 4 equals 0. The way you would then answer that is by saying, well, we've got this piece in the front over here. So our first factor would be x, and our second factor is x minus 4. So your solutions would then be x is equal to 0 or x minus 4 is equal to 0. And then we would say x is 0 or x is 4 when we move that over. So we're going to use the exact same principle here, where we look at the two factors that we've been given, and then we equate those factors to 0. So when we do that, we will get our first factor as cos x, and our second factor is 1 minus 4 sin x. So that tells us that our first factor must equal 0, so cos x will equal 0, or 1 minus 4 sin x must equal 0. Now it becomes easy because, do you see, we've got our ratio equal to a number. That's our goal always. Second one, we've got a ratio and we can simplify it out. So when we simplify this, we'll get that sin x is equal to 1 over 4. In both cases, we've got a ratio equal to a number. And so we can go ahead and solve a general solution over here and over here. And if you think back to it, we know that a cos general solution gives us 2 answers, and a sine general solution gives us 2 answers. So in total for this question, there will actually be 4 answers to this question over here. And let's see how exactly that works. So the first one, we know from the formulas that we've been given that to solve for the cos general solution, we would say that the angle, which is x, is equal to plus or minus the inverse cos of 0 plus k times 360. And then likewise for sine, we know that x for the angle will be equal to the inverse sine of 1 over 4 plus k times 360, or x will equal 180 minus the inverse sine of 1 over 4 plus k times 360. And so if that's the case, we can simply go and take our calculator and plug the values in. The inverse cos of 0 is 90. So our first solution will be plus or minus 90 degrees plus k times 360. And obviously, because of that plus or minus in front there, we know that we've got 2 answers over there. And then we're going to do the same thing for sine. So we know that the sine, we will go shift sine to get our reference angle, which is 1 over 4. Gives us 14.48 when rounding off to 2 decimal places. So 14.48 plus k times 360. Or x is equal to 180 minus that 14.48. So we'll go 180 minus the answer, which gives us 165.52 plus k times 360. And make sure you don't forget, k is an element of integers. And you can see 2 solutions there, and then 1 solution there, 1 solution there. And that's our final answer for this question, where we have 4 solutions. So it was taking out that common factor, using this idea of making both factors equaled to 0, which we call the zero product law, and then solving it like any other equation. In this third example, you can clearly see that this question is in the form of a quadratic equation. It's got that form ax squared plus bx plus c equals to 0. And anytime you have a situation like that, where you've got one ratio, so we've got sine, and we can see that it's clearly got a squared and then a power of 1, and we've got those coefficients a, b, and c, we could solve this using the quadratic formula. So you can almost pretend that this equation here is actually 6x squared plus 7x plus 2 equals 0. But obviously instead of x, we've got sine. And so our quadratic formula, when we went to use it, would actually be, instead of x is equal, it would become sine of x is equal. And then our coefficients would be, we know that a is 6, b is 7, and c is 2. So it would become negative 7 squared plus or minus the square root of 7 squared minus 4 times a times c all over 2 times a. And when we go and plug that in our calculator, we will get the answers of negative a half. So we would say sine x, not x, because we're dealing with a trig general solution. Sine x is equal to negative a half, or sine x is equal to negative 2 over 3. Again, we've got a ratio equal to a number, ratio equal to a number. So then we can go ahead and apply our general solution. The general solution for sine is that the angle is equal to the inverse sine of a half plus k times 360, or x is equal to 180 minus that inverse sine of negative a half there, plus k times 360, or x is equal to the inverse sine of negative 2 over 3 plus k times 360, or x is equal to 180 minus that inverse sine of negative 2 over 3 plus k times 360. And then, of course, you would just go and plug these values into your calculator. And when you do that, you would get the following. And so once you got that, you can simply group the like terms for these two over here. And that would give you a final solution of 210 plus k360 and 221.8 plus k360, where k is an element of integers. So there's solution 1, solution 2, solution 3, and solution 4. The final example in this video makes use of a trinomial. And the difference between this question and the previous one that we tackled is the fact that instead of having just one trig ratio, now we've got a cos and a sine. So we've got two different trig ratios in the same question, and both of them are squared. Now, the way that you would often figure out if you needed to use this particular method is by looking at the central term and asking yourself, does it have a sine and a cos in it? And what you'll notice that if you've got that central term and you've got a sine and a cos that isn't squared, then you will have to factorize it as a trinomial. However, if this central term had only had a sine in it, then what you could have done is actually used an identity in place of cos squared and made it 1 minus sine squared x, and then gone about simplifying the equation and treating it like a normal quadratic equation. But because it's got a sine and a cos in that central term, we can't do that. And so we would have to factorize it as if we had something along the lines of x squared plus xy plus y squared equals 0, where we would get two brackets like that, and it would be something like x plus y, x plus y. So that's the kind of idea that we're going with in a question like this. And it becomes quite straightforward actually when we deal with it. So it is an advanced trinomial, and you'll remember how to factorize these more or less. But we're going to start off by getting two brackets in. And when we've got those two brackets, you're going to look at the factors of the first term and of the last term. And so we know we've got the factors 2 and 1. That's for the first term over here. And then for the third term, we've got negative 3. So the factors of 3 are 3 and 1, or 1 and 3. And some of you might remember that cross method that you used to use earlier on. And so when we use that cross method here, you will see that 2 times 1 is 2, and 1 times 3 is 3. And we need to figure a combination of them that we get the coefficient of this middle term there. And you can see that that middle term is obviously got a coefficient of positive 1. And so the way to get that would be to have negative 2 plus 3 is equal to 1. And so that tells us then that there will be a negative in front of the 1 there, because it's attached to the 2, and that there will be a positive in front of the 3 as it's attached to the 1. So you can almost see how we needed to get negative 2. So we put the negative in front of the 1 because of the 2 times 1. And we had to get positive 3. So we put the positive in front of the 3 there. And then you can put your bracket round each piece like that, because this entire piece will be one factor, and that entire piece will be the other factor. And so we would have 2, and we would write it with the cos x, and then it will be plus 3, and we would write that with the sine x. And then obviously for the second bracket it would be 1, which we don't need to write, so it would become cos x minus sine x. And if you went and multiplied that bracket out by foiling it, and you can do that in your own time, you would actually see how we get this expression above. And so we can now apply that zero factor law, which says take each of your factors, so there's factor 1 and factor 2, which basically means take your brackets, or whatever's inside your brackets, and make them equal to 0. So we're going to have 2 cos x plus 3 sine x equals 0, or we're going to have cos x minus sine x equals 0. Do you also see now we've got different ratios, same angle in both of them? Different ratios, same angle. And so because of that, we then know that this is an example of type 1. And in type 1, we would firstly get sine by itself. So move the cos over in this equation over here. And so it would become 3 sine x equals minus 2 cos x. And then we divide both sides by cos x. The cos x and the cos x will cancel. And here we've got sine over cos, which using our identity, we know sine over cos is tan. So we get 3 tan x equals negative 2. So therefore tan x is minus 2 over 3. And on this equation over here, we do the same thing. We're going to get sine x is equal to cos x. If we move that sine x over, we divide both sides by cos x. Divide both sides by cos x. The cos and the cos will cancel. Sine over cos becomes tan. So we get tan x equals 1. And then we've got to use our tan general solution. And so our tan general solution will give us x is the inverse tan of negative 2 over 3 plus k times 180. Remember, it's 180 when we use tan. Or x is equal to the inverse tan of 1 plus k times 180. Don't forget to say k is an element of integers. We plug that in our calculator. And so we'll go shift tan of negative 2 over 3 over 3. That gives us negative 33.69. Negative 33.69 plus k times 180. Or x is equal to the inverse tan of 1. And that gives us 45. Plus k times 180. And there are our two solutions. The very tricky part here, factorizing the trinomial. So if you struggle to factorize trinomials like this, go and watch the video that deals with factorizing in trigonometric expressions, or even go back and look at your grade 10 textbook on the more complicated forms of factorization that we did, such as grouping, or even these really advanced trinomials where we had x's and y's, or more than one variable, like the sine and the cos, in a question. So that's the end of type 4. In the next video, we're going to look at type 5, where we take everything together and we start introducing trig identities as well.